So when it comes to automation, the typical questions will be around, well, who is in control and when? How do I know that the car is in control and it's driving for me? And how do I know that the car cannot any longer be in control and I have to retake control? Can I trust it? If it goes wrong once, will I trust it again? And also, is it acceptable and reliable and so on? And the possible consequences of automation, not all of which have been studied in cars, include loss of skill. So you may all have some kind of alarm for parking, sort of forward collision or something like that. Do you end up relying on that more and forget really whether to even look at whether you're at the right distance from the car or not? Loss of situation awareness. So if the system is in control and it's suddenly out of control, you might wonder where you are if you were thinking about something else and you have to take control. Changes in workload is a very important one. Some would argue that if the car is automated, then your workload, the level of attention, etc., you have to give to the driving task is lower. Possibly, you could even argue that you could fall asleep. But what about when you have to retake control? You go from a very kind of low, happily looking around to, oh my God, what's going on? High workload, and that can be very dangerous. Issues around behavioural adaptation and misuse and abuse. You could argue that if automation is in charge, you'll think, well, I can go to sleep because that's going to drive for me. I can have a drink tonight because my car will take me home, etc. These are all things that at least should be considered when looking at automation. Okay, so I'm just going to give you a little bit more of a detail now. So we did some experiments in our driving simulator, and I'll explain the experiments in a moment, but if it works, or not, I think you just need to press on that's it. Perfect. Okay, so I don't think I've got sound for this, which is good. So this is our driving simulator, which is a dynamic, fully motion-based driving simulator. And I'm not just saying this, but it is the most advanced one in the UK. And this was actually some filming done by the GMTV, for those of you who are in the UK, on the danger of talking on the mobile phone and driving. And it was great because we basically set up the experiment so that the guy, this is the TV presenter, we phoned him up and then we caused an accident in the middle of the driving simulation, and he had to stop, and he basically crashed the car because he was distracted by driving. And it was done live, so it was really great to prove the point. So we used our driving simulator to look at how automation affects human factors, and I'll just explain 2 or 3 slides of the sorts of things that we did. We looked at both motorway driving and urban driving. This is through a series of experiments from different projects funded by the UK and also the European Commission. First of all, we wanted to look at what people would do if the car is automated. We gave them a load of things to look at, to eat, to drink, to watch TV, etc., and just to see whether they would take part in any of these. And we looked at manual driving, semi-automated driving, so either lateral or longitudinal control, and fully automated, where the car was driven for them, basically. And it was a little bit disappointing because I didn't do anything terribly exciting and out of all the things that they were given. They mostly just listened to the radio. But they did watch a DVD that was provided, and they could choose what they wanted to see. And they looked at the DVD more, maybe not surprising, in the automated situation compared to the manual and the semi-automated situation. Admittedly, all of these are done in a driving simulator, so how realistic they are in the real world, I will reserve judgment on that for now. We also used an eye tracker to see where they would look. So we divided the screen up into 5 parts, and this is based on research was basically suggests that most people look in the centre of the road because that's where most things are happening. But we looked at how much they look to the left, right, up and down. And you can see as automation increases, the percentage of time they look in the centre of the road decreases significantly, and they look around a lot more. Not surprising again, because the car is driving for itself, so they can look around a lot more often. We looked at, again, using the eye tracking, whether they felt sleepy or not, and that's basically a perk close is a measure of how much your eyelids drop. And as you can see, there's manual driving and automated driving, and the main thing was that in the light traffic, when there wasn't much going on, they had their eyes closed, so were bored and sleepy, much more so. But they did come down and kind of pay a bit more attention as traffic increased, even though it was in automated mode. They thought, oh, you know, better keep an eye just in case there's going to be an accident. We also looked at how long it would take them to come back into control. So here is this idea of the percentage road centre, so how often they look in the centre of the road, and obviously 100% of the time is best. And here I'm looking at the automation coming off. Where are they looking, and how long does it take them to kind of come back into the loop? And we looked at both eye tracking and control of the steering wheel and control of the pedals, etc. But I'm only going to show you the eye tracking. And my estimation is, and this is true for all of the other measures, that it takes about 20 seconds from the automation turning off to them retaking control. So 20 seconds, I mean, you know, this is the first and only study that's been done, so I'd like some more evidence before I can really argue the case. But 20 seconds feels like a long time to resume control. Okay, and the final slide in terms of how they react is some work we did for the City Mobile project on whether or not they react in time to a car in front of them. So this was in an urban environment, and basically the blue shaded area is when the automation comes on and they get some HMI which tells them that the E-lane, as we called it then, is active, so they take their hands off the steering wheel and let the car drive. And then we provided them with some scenarios where the lead car, which you can't actually see there was a lead car in front of them, and that would brake in response to something, and we looked at how quickly they reacted to the lead car braking. And here are some results. So oncomer turns across, so a car basically comes in front of the lead car and they have to react. Traffic lights turn red suddenly, and emerger, something comes in from, and remember we're in the UK, from the left. But the main idea is how quickly do they respond to the lead car braking when they're in automation, and they have to take control. And as you can see, they're always quicker when they are in control of the car compared to when they have to resume control from the automation. Okay, so their reaction time wasn't that great. I should add here, actually, this was true for the urban scenario. When we did it in the motorway scenario, there was no difference between automation, so they didn't seem to be slower compared to manual driving. Not quite sure why that is at the moment. Just might be a difference in scenarios and environment. Okay, so just to finish up, some concluding remarks, and why is this relevant to you as riders? Okay, so there is basically, as I argued at the beginning, there's an increasing implementation of technology in the vehicles. And I will say, in the last 5 years maximum, there is now an interest in how the drivers are interacting with this technology. So up till then, I can safely say, and I've spoken to engineers and designers, etc., it was about making sure the system works. And still, only now, really, are we looking at how the drivers interact with these systems. And still the situation is that it's the driver in the car, so an individual driver in an individual car. That's where the research is at the moment. We are not, at the moment, looking at how other cars are interacting with these systems, how it affects traffic, how other people, VRUs, etc., are interacting with the system. That's still research to be done. But for now, the challenge is really to make sure that the drivers are interacting with the systems correctly, they understand what the system is doing, and they are adequately trained to use the system and not abuse it. I'll just mention these projects and activities which are really where the research is going. So the Adaptive project, which has just started an IP on funded by FP7 on vehicle automation, and there's a big degree of looking at the human side of things, the driver side of things anyway, and the VRA project, which is actually funding my visit today, and that's vehicle road automation, and that's looking at all aspects from all stakeholders, not just from the human factors side. And there's also a lot of activity from Ertico and the iMobility Forum and the Transportation Research Board on this, picking up, looking at workshops on the human factors of driving, automated driving. And what we are left with now is looking at not just now, but also in the future, what are the long-term effects of automation? What are the effects of automation on other traffic, as I mentioned, and the reaction and interaction with VRUs. And there is a slide there, it's gone. Let's see, there it is. Just mentioning one other activity that I'm involved in, this is the City Mobile 2 project, which is looking at what we call level 4 fully automated public transport system. So not your sort of Google car, but that kind of looking cyber car. And here I'm looking at the interaction of other people with the car. So I mentioned briefly how we were doing some interviews, and one of the challenges with automated vehicles is knowing that it's an automated vehicle. Obviously that's quite, you can tell because of what it looks like. But if it's a normal looking car, you don't know as someone outside it, whether you're in another car or whether you're a rider or whatever, what it looks like. So the sorts of things that we're asking people is, what do you need to know from the car when you're interacting with it? Obviously when you have a driver in there, you look at each other and you say, is it all right if I cross or whatever? You don't have that in a driverless car. So there's quite a lot to be looked at from the outside of these cars, including riders. So before I say thank you for your attention, I just want to say one other thing, which is how is this all relevant to you guys as riders? I mean, these are just food for sorts of things that you might want to think of when you're talking about implementation of systems into motorbikes. But we've said again and again how different the environment is, the drivers are from riders. And the most important thing is the actual environment that you're driving in. So if that you're in, if you're a driver, you're in a nice comfortable car and lots of things are happening that you don't have to pay attention to all the time. I guess, and I'm only talking about it because my husband's a rider, when he has a long ride, he's actually very tired, quite a high workload. So when you're thinking about implementing ITS, I think you cannot compare, you cannot even start to say, okay, this is what's happening in cars, let's see how it's relevant to bikers. We had an interesting presentation from a pilot at the Driver Distraction and Inattention conference, where he was saying, don't look at pilots for trying to understand what automation does to drivers. And I think the same is relevant further down the road, that you don't want to be distracting the riders. You don't want to be providing any more than they have to do so. And I think that's a challenge. I don't know what the solution is. Maybe Alex will provide some, but that's what I want to leave you by.